This video is about the layer 2 of the OSI model, that is the data link layer. Welcome to the world of physical addressing. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 22, Data Link Layer. Learn CCNA with iRush Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar. In this chapter, we will discuss about the data link layer of the OSI model. We will discuss about the MAC addresses. Then finally, we will discuss about the data link layer functions. So let's talk about the data link layer. So the data link layer is the second layer of the OSI model. Starting from the down, it's coming right after the physical layer, and from the top it is after the network layer. In the screen you can see the OSI model at your left side and the TCP IP model at your right side. The OSI model has 7 layer and TCP IP model has only 4 layer. So whoever created the TCP IP model, from their point of view, after the application layer and the transport layer and the internet layer, there is only one function remaining, that is belonging to the network access layer, this one. But for the people who created the OSI model, from their point of view, after the network layer, there is 2 more functions that need to be considered. It is the function that performed by the data link layer and the physical layer. For those who created the TCP IP model, the function of the data link layer and physical layer they consider as a single function, that is belongs to the network access layer. But for the OSI model, that is not enough. They separated the network access layer into 2 layers. One is the data link layer and one is the physical layer. From their point of view, they are performing different kind of task which need to be considered when you create a network. So that's why there is a difference at the bottom layer on OSI model and TCP IP model. Now what is the main function of data link layer at the OSI model? The main function of data link layer is manage the physical addresses of the network. So what is this physical address? In a network there is 2 kind of networking address. One is the logical address, that is called the IP address, and the another one is the physical address. Physical address is also called the MAC address. So what is the difference between the IP address and physical address? We know that in a network, for every network device, they should have a network interface, whether it is wired or wireless, to connect to the network. So this interface, it should have an address, that is the physical address. So this address is something designed by the manufacturer of that devices. They induce an address into that interface while manufacturing the device, and we call it the MAC address. MAC address stands for Media Access Control Address. This address is something designed and integrated by the manufacturer of the devices, and this cannot be changed under the normal circumstances. On the other hand, the IP address are the logical address, that is designed and provided by the people like you and me, the network engineer, to the devices in a network. Can we change the IP address? Yes, of course. We can change the IP address and we can put any address that we want. Doesn't matter the number. You can change IP address of a device to n number of time without any limit. But on the other hand, the MAC address we cannot change because that is something integrated with the physical interface of the device that cannot be changed. So in the previous chapter, we were talking about the network layer, and we said that the network layer manages the logical addressing part of the network. They manage the IP address. On the other hand, the data link layer, they manage the physical addresses of the network. That means the MAC address or the Media Access Control Address. Now let's talk about the MAC address. What is a MAC address? MAC address stands for Media Access Control Address because it is the address that control access to the media. It is also called hardware address or physical address. It is a unique 12-character alphanumeric attribute that is used to identify individual electronic devices on a network. So how do a MAC address look like? We have given 2 examples of MAC address in the screen. This is how a MAC address look like. So as we said, The MAC address is a 12 character alphanumeric attributes. So in this screen we can see the MAC address has 12 character. If you count this character, we can understand there is 12 character. And what is the other specification? It should be the alphanumeric. Here you can see the MAC address should be a combination of numbers and alphabets. We cannot have the MAC address only which contain the numbers or only the alphabets. It should be a combination of numbers and alphabets. So that's why we call MAC address is an alphanumeric attributes. Now when we look into a MAC address, we can see there are 12 characters. The first 6 character is called organizationally unique identifier or OUI. The second 6 character is known as network interface controller specific or NIC. So what is the difference between these two groups? So the OUI number is provided by the IEEE. IEEE is called the Institute of Electrical and Electronics Engineer. It's an authority who is designing and providing the MAC address to the devices. So the first 6 character of a MAC address denote its organizational unique number. It identifies the manufacturer. Who is the manufacturer? It is pointing to the company who manufacture this device. In this screen you can see the OUI number registered under some of the famous companies in the networking industry. You can see the OUI number of Cisco and Google, Hewlett-Packard and Huawei. So if you see a network device, its MAC address is starting from CC46D6, then you can say that device is manufactured by the Cisco. It's a Cisco device because this is the OUID of Cisco. And if you see another device in your network with a MAC address starting from 3C5AB4, then you can say this device is manufactured by the Google. It's a device from Google. So in this way, we can identify the manufacturer of that device from its OUI ID. Now on the other hand, NIC number is provided by the manufacturer. So the last 6 character is decided by the manufacturer. The first one, the OUI ID, is designed by the IEEE committee. That cannot be changed by the manufacturer. They cannot manufacture a device with a different OUI ID that is provided by IEEE. But they can decide the last 6 character of the MAC address. So that is the network interface controller specific or NIC ID. Even though the same manufacturer should not use the same NIC for 2 devices because they will be duplicated. So each device they provide different ID. Now let's discuss what is happening at the data link layer of the OSI model when there is a network traffic. To explain this scenario, I am taking you to the electronics shop that I visited to purchase a home theater system. So in all of our previous chapter, we were talking about with the multiple layer functionality in the OSI model. And we need to repeat the same process again to explain the functionality of the data link layer. So first of all, this is our client machine. 10.1.1.50 is the IP address of the client machine. When it creates a sales order, it is preparing a data and data that need to be sent to the sales application that is located in the server, and this is the IP address of the server 10.1.50.100. So these two network, the server network or the store network, they didn't connect it together. Maybe this server network is away from the store network. Maybe it's on a different building, even at a different country. So in that situation, the communication, it must happen through the network. Maybe there are multiple network in between, maybe 50 network or 100 network, depends on the design and distance. So first of all, the client PC prepare the data and the data is ready with the client PC. Now when the data is ready, what is next? This data must send to the server. For that it's need to go through some process. First of all, we will start from the application layer. So here the application layer helps for the communication between the application and the network. So application data helps to send this data over the network. It is always communicating with the network and the application that is hosted in the PC. Then when we go to the presentation layer convert the data into a generic format so that the other destination device can easily understand. Why we want to do that thing? Maybe the language written in the application at the client PC, it may be different from the server side. So they need to communicate together and they need to understand together. For that, the presentation layer helps to convert the data into a generic format so the server can easily understand. Now when we go to the next layer, it is the session layer. The session layer start and end the session. For sending and receiving a data, it's considered as a session. So before the client machine send a data, the session layer, they must start a session, help the client PC to send the data to the server. Now when we go to the transport layer, so in the transport layer, the application choose the network protocol that it need to be used. It may be TCP or UDP. It is how it is written in the application. Some of the applications are using TCP for reliable connectivity. Some of the applications are using UDP for non-reliable communication. Now it is going to the network layer. So what is happening in network layer? The network layer manages the IP addresses. So we know this PC has an IP address here, the client PC, and the server has an IP address, and this router has an IP address, and each interface of this router has an IP address, a lot of things. So this network layer manages the IP addressing part. Now it is going to the data link layer. And what is happening in the data link layer? We already said that the data link layer manages the physical addressing part. So now let's imagine this PC with IP address 10.1.50, it's need to send the data to the 10.1.50.100. Okay, so it's need to send the data, so it is sending the data through the network. Now in that network, this switch is the one who create the network connectivity in the showroom network. So all the network devices in that showroom is connected to this switch. We know the basic principle of switch is to learn the MAC address and then send the data accordingly. So this switch learn the MAC address of all the devices in that network. It is including this router interface, which is considered as a default gateway. So when the data is moving, its destination is 10.1.50.100, this one. But in this network, the switch cannot see this IP address. From its MAC address table, it cannot see any MAC address is binded to this IP address. So it cannot directly deliver this data to that IP address. So in that situation, switch forward that traffic to the default gateway, that is the interface of the R1, the router R1. So why the traffic need to go to the default gateway? The traffic will move to the default gateway only if it cannot find the destination in the same network. It is a simple logic. You cannot find that IP address in your network, so maybe this IP address is available outside the network, but we don't know in that network where it is located. So we are sending that traffic to the default gateway. Let default gateway manage the network communication. So when the router R1 receive that traffic in its interface, it is looking to that traffic and it can understand this traffic belongs to 10.1.100. This router network is 10.1.2.0 network. So it can understand this device is not available in this network and it doesn't know where to send this traffic. So here in this case, the router R1 check with R2 and asking about this IP address, server IP address. So R2 also check in this network and its network is 10.1.3.0. R2 cannot find this network 10.1.50.100 in that network. So it doesn't know where it is exists. So R2 check with the R3 and forwarding to R3 and asking, do you know this network 10.50.0? Then R2 check its network interface and it can understand that one of its interface is connected to 10.1.50.0. So it's understand, it only know this device is connected in that interface, but it doesn't know in that network where is this device located. So R3 send that traffic to the switch number 2. Again, this is a network switch and what is its main function? It learned the MAC address of all the devices that is connected to it. So here the switch already learned the server with IP address 10.1.50.100. It is connected to the interface of the switch. And switch know which interface it is exactly. Now, when the data that is pointing to the IP address 10.1.50.100, it's coming to this network, the switch can understand this data belongs to this destination, that is the server. So it will forward that data to the server directly. Now the server receive the data. So this is what happening in a network communication. So mainly in the data link layer, the physical address or MAC address helps to deliver the data without any error. And when the data is passing through each layer, there is an addition of the information adding to the data, and this information also will pass through the network. For example, we know our data is ready and it is going through the application layer, then it is going to the presentation layer, and it is going to the session layer. They are mainly working with the application itself. And when it is passing through the transport layer, there we need to specify the destination port number and the source port number. And when it is moving through the network layer, we need to specify the destination IP address and the source IP address. And again, when it is moving to the data link layer, we need to specify the destination MAC address and the source MAC address. So this is what happening when the data is passing through a network, through all the layers in the OSI model. Now let's talk about the functions of the data link layer. The point number 1, it's framing. We know the data link layer exists in between the network layer and the physical layer. Network layer manages the IP address part and the physical layer manages the physical connectivity. So what is the function of data link layer in between? When the data is passing through the network layer, it is called packets. When the data link layer receives this packet, it divides into multiple small pieces, which is called frames. Frame means the pieces of data. So these are the frames. And data link layer send these frames bit by bit into the physical layer. So basically it is receive the data packets from the network and then convert into the frames. That means the small piece of data, then send each frames bit by bit to the physical layer. So this is the basic functions of the data link layer. And not only that, when the data link layer send the frames to the physical layer, it attach some special bit at the header and end of the frame. For example, if this is the frame that data link going to send to the physical layer, then they attach some special kind of bit here at header and at end. This is using for what? This is using for the error control and addressing. Now we are talking about the sender side scenario. When the data link send the frame along with this special kind of bit for error correction, at the receiver side, the data link layer analyze the received frame and consider it is a complete frame. For example, when the sender side sending the frames without this special error correction bit, then when the data link layer at the receiver side, when they receive this frame without this bit, they will think that this frame is not complete or this frame is incomplete. So it will expect the complete frame again. That causes the connectivity error or data transmission error. So to avoid this situation, data link layer adds some special kind of error correction bit, so the receiver side can receive the same bit and it can understand that frame is completed and it is a complete frame. In the same like sender side, in receiver side also, the data link layer function is to receive the data from the physical layer, that is in the form of zeros and ones, because in physical layer data is passing as zeros and 1. And when the data link layer receive the zeros and 1, they convert that data into small frames, same like in sender side, and send this frame into the network layer. So basically in network layer the data is called as packets, and in data link layer data is called as frames. Now the second function of data link layer is addressing. So what is this addressing means? The data link layer encapsulates the source and destination MAC address in the header of each frame to ensure node-to-node delivery. MAC address is a unique hardware address that is assigned to the device while manufacturing. So in this network diagram shown in the screen, there are multiple network devices connected to a single switch. All these devices together form a network. Here we have 3 PCs and 1 server. Suppose the PC1 want to send some traffic to the server, then how the data link layer manage the addressing part? We know that the MAC address means the physical address of the networking device. So here the MAC address of the PC1 is this one, and the MAC address of the server is this one. So when the PC send the data to the server one, it is sending the form of frames. Frame means small portion of the packets. So for each frame that the PC is sending, it is adding the source and destination MAC address into that frame. Basically saying it encapsulates the source and destination MAC address as a header and integrate with this frame. So when the frame is passing through the network device, here the switch, it can understand the data is coming from the source MAC address, that is the PC1, and it is going to the destination MAC address, that is the server 1. So it delivers the data very efficiently to the destination without forwarding that to the other devices in that network. This is the concept of addressing in the data link layer. Now function number 3, error control. The data can get corrupted due to various reasons like noise and attenuation, etc. So it is the responsibility of data link layer to detect the error in the transmitted data and correct it using the error detection and correction techniques respectively. Data link layer add error detection bits into the frame's header so that the receivers can check receive the data is correct or not. It add reliability to the physical layer by adding mechanism to detect and retransmit damaged or lost frame. We all know that the data is passing through the cables. It can be a copper cable or fiber cable, or even it is passing through the wireless. So there is a possibility that data can get corrupted because of any noise or attenuation in the medium. Medium means the transmission medium like a cable or fiber, etc. So one of the function of data link layer is to detect the error and transmit the data correctly to the destination. So data link layers are using some error detection and correction method. They add some error detection bits in the frame while they are sending the data. So when the receiver say receive this frame, they will check the error detection bit in that frame. So if there is any change in that error detection bits, that means there is an error in the data transmission. And sometimes data is getting lost because of the problem in the media. So all these problems are addressed in the data link layer, and they use an effective method to control this transmission error. Now function number 3, flow control. If the receiver's receiving speed is lower than the sender sending speed, then this can lead into an overflow in the receiver's buffer and some frame may get lost. So it's a responsibility of the data link layer to synchronize the sender and receiver speed and establish flow control between them. In the screen you can see one PC and server is connected to a network. Here PC is the sender and server is the receiver. So here what is the speed of the PC? From the network diagram we can say the speed of the PC is 1000 Mbps, which is equal to 1 Gbps, 1 gigabyte per second. That is 1000 megabit per second. And what is the speed of the server here? The server speed is 100 Mbps. So from this network diagram it is very clear that the PC speed is higher than the server speed. So just imagine the PC sending the data at 1 Gbps speed to the network and server receive the data at 100 Mbps. So what will happen? Here the sending speed of the PC is very much higher than the receiving speed of the server. So the PC is sending more data in higher speed, but the server cannot accept all the data together. It can only accept as per his speed defined. So it receives some of the data and the remaining data that is going to the buffer. So buffer means an extra space that store the sending data. So here the buffer has a capacity to store the data. When the PC send more and more data, the buffer is getting easily filled and it's going to the state overflow. So in that situation, there is a possibility of losing the data. So in this situation, data link layer control the flow in very efficient way. It try to synchronize the speed between the sender and receiver into the same speed so that they can send the data and receive the data without any transmission error. So this is one of the another function of the data link layer, that is the flow control. Another function of the data link layer is the access control. When multiple devices share the same communication channel, there is a high probability of a collision. So it is the responsibility of data link layer to check which device has control over the channel, and that can be used to avoid the collision and loss frame in the channel. So consider the network diagram showing in the screen, where we can see 3 PCs and 1 server connected into a single devices. Just imagine this is a network hub. Now what is the problem with the network hub is there is only one collision domain. There is only one channel for sending and receiving the data between the multiple devices. So that single collision domain is divided equally in between the all devices in that network. So that means it is divided in between this 3 PC and 1 server. So in a single collision domain, only one device can either send or receive the data at a time. It is not allowed to do both send and receive the data at the same time. Or it is not allowed to do send two devices together at same time. Only one device is allowed because there is a single collision domain. So what will happen when two devices try to send the data at the same time? When two devices try to send the data, the collision can happen in that single domain. Both the data collide each other and they cancel each other. So to prevent that thing, there is a concept of collision detection and collision avoid. So by using this concept, if any device is trying to send the data, first of all, it is checking whether the collision domain is free or not. If the channel is free, then it sends the data. At the same time, if another device tries to send the data, it can understand there is already one communication is going on, so it will hold its data until the previous communication complete. So how this concept is effectively managed in a network with multiple devices by using the access control. So this is one of the data link layer functionality to control the access to the transmission channel to avoid collision and loss of frames. So in this chapter, we have discussed about the data link layer of the OSI model. Then we have discussed about the MAC addresses. And finally, we have discussed about the data link layer functions. Thank you very much for watching and subscribe to the channel for more videos.